Today we're going over lessons 11.1 and 11.2 over areas of triangles, parallelograms, trapezoid, rhombuses, and kites. Just a note that chapter 11 is over measuring length and area before we move on to chapter 12 about surface area and volume. So we will be combining some of these lessons as they've been taught in earlier chapters, like lesson 1.6.7, I believe, covered triangles, parallelograms. But anyway, then we'll move on to perimeter and area of similar figures. That has an interesting property. To circumference and arc length, areas of circles and sectors, and then the last two lessons, area of regular polygons and using geometric probability. Lesson 11.1 starts out with a recap of some of these area postulates. Area of a square is area equals side squared. Area congruence means if two polygons are congruent, then they're going to have the same area, right? Triangle ABC congruent to triangle DEF, well, ABC's area will equal DEF's area. Area addition postulate will happen if we have a composite figure, like let's say we have this square and then we have a triangle off the square, right? The area of the full would be area of square plus area of the triangle, right? Area of a region is the sum of the areas of its non-overlapping parts. The area of a rectangle is a product of base times height, right? Area is base times height. Next area, we've got area of a parallelogram is also base times height. Now notice, it looks like we've got triangles. However, if we chopped, right, this part of the parallelogram off and attached it over here, it would look precisely like a rectangle, which is why base times height worked, and we don't need to do anything different for calculation. Lastly, area of a triangle is half that of a rectangle, so it is area equals half base times height. Now notice height on both of these are perpendicular to the base we're coming from. That is required to find the height. We can't just take any value and call it height. We need to have a perpendicular right angle there for us. Moving on to finding the perimeter and area of the polygons. So we've got this polygon over here, which is a triangle, right? Notice there's 4 different details given to us. We have this height, right? Because we got the right angle. We've got 3 on the outside for perimeter reasons. We need all 3 to find the perimeter. For area, we only need 2 of these, right? So where's our height? Right here, 8. So 8 and 21 are going to be involved with the area. But perimeter first, we're adding just all 3 sides, right? For perimeter, you add the outsides. 8 is not included. 8 is not outside, right? Outside 17, outside 21, outside 10. Add those together, 17 plus 10, 27 plus 21. I get 48 units. Next for area, area is half base times height. And again, this is one of those where a lot of people remember it, but when it gets to the test quiz, often forgotten or applied down here, right? Half base times height, so I do half times 21 times 8. Typically, if I'm doing this by hand, I cut one of my even numbers in half. So half of 8 is 4. 421 is 84. And 84 units squared is my answer. Again, units squared for area because we have square units, and 48 units singular for perimeter. Same thing if it was centimeters, inches, squares, feet, meters, feet, etc. Next one, we've got a parallelogram here, right? So parallelogram tells you base times height. Now perimeter first. Reminder that opposite sides are congruent, right? So we've got 30 and 30, 20 and 20. So I just added 2 of each. We got 20 plus 20 plus 30 plus 30, and that is 50, 50. I get 100, and I don't see a unit, so we'll just call it 100U for units is my perimeter. Area is just base times height, so here's the height, 17. We've got the right angle, 17. 17 times 30 is going to be 510 units squared. It's not always true that area is more than perimeter, but in a lot of times it is. Next, we're moving on to a right triangle here. They only gave us 2 sides. We got 5 and 13, but because it's a right triangle, this down here could be considered base. This could be height, or we could say A, B, and C for A squared plus B squared and C squared. And that is what we need to do first to find A. And so A squared plus 5 squared equals 13 squared, because 13 is the hypotenuse. So we're going to subtract the 5 squared from each side, which is 25, to get 13 squared minus 5 squared leaves us with 144. And what times what is 144? That is 12 is our square root. So now we have a is 12, and we can do perimeter is 5 plus 12 plus 13, which adds equal 30 units. Area is half times 5 times 12, because 5 could be considered the height, and 12 is the base. I also actually did it in 12 times 8, 5, pardon me. So half of 12 is 6. 6 times 5 is 30 units squared. Moving on, we've got the base of a triangle is 3 times its height. The area of a triangle is 54 centimeters square. Find the dimensions of the height and base. Now, most of these, it is very beneficial to draw a picture. Some people could tell me area of a triangle is blah, 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 but they could tell it more if they saw it. So I draw a picture. They did tell us the right triangle. It's a little bit shaky, but we've got a triangle here. Base is told to me is 3 times the height. Whereas height, I just kind of drew it there. So we got 3 height and height. That's only one variable now that we have it that way. So area is half base times height. I'm going to plug in 3 height for base. And now I'm going to plug in 54 for area. So 54 equals half times 3h times h, which is just 3 half h squared. Right? 3 over 2 h times h is 3 half h squared. And now when we have a fraction like this, you can cross multiply and divide like a proportion just with the 3 halves, so times 2 divided by 3, and we get 108 divided by 3 gives us h squared is 36. What times what is 36? H is 6. Now it says find the dimensions of both of the triangle, but what it means both the height and the base. So height is 6, plugging it back into the base. Base is 3 times 6, and therefore 18. You do need both of those answers. Moving on, application problem. You need to buy paint so that you can paint the side of a barn. Given here, a gallon of paint covers 350 square feet. How many gallons should you buy? Well, first we need the area here. And so they gave us this square-like looking shape. However, they say the height is 34 feet, the width is 30. And so parallelogram, right? 4 right angles gives us parallelogram, probably a rectangle, right? 4 right angles rectangle, but opposite sides are equal in a parallelogram, so we've got 30 up here, and we can just do area of the rectangle is 30 times 34. Now we need to do area of the triangle. Now the triangle is a 45, 45, 90 triangle. Well, how do we know that? Right here. Isosceles, those two sides are equal, and right angle. So right isosceles triangle is the 45, 45, 90, which has the pattern of x, x, x root 2 for hypotenuse, and we know hypotenuse is 30 because opposite sides are equal. So x root 2 is 30, and so x equals 30 over root 2, and technically we can simplify. However, we just need this for area. So I'm just going to leave it like that because we're going to use our calculators. That is equal to both of these marks, which is going to be both the base and the height. So my next calculation, we're going to add the area of the triangle to this area of the rectangle, and it's half 30 over square root of 2 times 30 over square root of 2. And my total area, when I add those two pieces together, was 1,245 feet squared. Now, most people on a long problem like that would say done. Well, how many gallons should you buy? My answer is not gallons. We're not done. So we're going to take the area total divided by 350 because they're both feet squared. And we're going to get about 3.56. Now, I don't see anywhere that says I can buy exactly 3.56 gallons, so you're just going to round up, right? Generally speaking, you can buy gallons in gallon, right? Paint in gallons. So we're going to need 4 gallons. It rounds up. And again, what if it was 3.3, just for a second? What if it was 3.3? It would still round up, because you can't just say, 3 gallons will cover it, because clearly we would need more than 3. Next, here's a proof, but it's more algebraic. Given the diagram, we want to prove that the area of this triangle here, area of ABC, is half FH, right, given the diagram. Now, we're not going to just use, well, base times height, right? What we're going to use is we're going to do the area of the large triangle minus the area of the small triangle to mathematically show that this, what we would call, not obtuse. It is obtuse. I want to say they call it oblique triangle, where my height's not a nice right angle next to it, has the same half base times height pattern, even if the height is not inside. So This is what I said we're going to do. Triangle ABD large minus triangle CBD small gives us triangle ABC. And so we can do triangle ABD is half F plus G times H, and triangle CBD, I distributed half FH, half GH. And now we're going to subtract CBD. Well, minus triangle CBD is minus half base is G, height is H, so that's half GH. And so now we've got area of the big minus area of the small to get area of triangle ABC. This half GH will fall off, and we get triangle ABC is half FH, which is half the base times the height. Kind of different proof there. A couple more, and then we'll call it good. Area of a triangle can be found using Heron's formula. Okay, area equals square root of side, semi-perimeter, pardon me, not side, semi-perimeter, times semi-perimeter minus side A, times semi-perimeter minus side B, times semi-perimeter minus side C. Oofta, right? Now, what is semi-perimeter? Semi-perimeter is half the perimeter, right? We add A, B, and C together and divide by 2 to get semi, half the perimeter. So find the area of the triangles. We're going to do a couple of these. We've got semi-perimeter here, 21 plus 18 plus 25 divided by 2. Right, so 39 plus 25 is 59 plus 5 is 64, and then half of 64 is 32 is our semi-perimeter. Now we're going to plug that in. So square root of 32 times 32 minus 21 times 32 minus 18 times 32 minus 25. And these order do not matter, right? Clearly it doesn't matter if this is A, B, C, or this is A, B, C, right? They're still going to get the same answer because each one's included. So we're not worried about base and height here. And so we plug that in. We got area equals square root of 32 times 32 minus 21 times 32 minus 18 times 32 minus 25. Now, as you do these more and more, you'll realize you can do 32 minus 21 in your head. So you probably won't need to write this whole step out, but for the first couple times, I highly recommend it so that you get it down. You could do 32 minus 18, 32 minus 25 in your head, right? I get 32 times 11 times 14 times 7. Rewrote that there. Calculator, 185.73 inches squared. In general, we're going to round to the second decimal. Okay. One more semi-perimeter problem. Go ahead and try this on your own. Now, see if you match my answer. I got the semi-perimeter was not a nice number, 56.5. Doing it, 56.5 times 56.5 minus 37 times 56.5 minus 41, and so on. And then we get 56.5 times 19.5 times 15.5 times 21.5 for a grand answer of 605.94. And that wraps up the 11.1 lesson. I'll start the next video with the 11.2 lesson.